Most people think statics and dynamics fundamentals, forces, equilibrium, kinetics, and kinematics is a complex idea that only makes sense after formal study. But the truth is that this concept was originally developed to solve very real and practical problems. Long before engineers studied it academically, people were already using its logic instinctively in everyday life. To see this clearly, imagine a simple situation where you push a heavy cupboard across the floor. You instinctively push harder when it doesn't move, ease off once it starts sliding, and stop pushing when it reaches the position you want. Without realizing it, this single action already follows the core principles of statics and dynamics, meaning you've applied the concept correctly in under a minute. What's actually happening here is simple. Forces determine whether an object stays at rest, starts moving, speeds up, slows down, or stops, and this behavior depends on how those forces balance or change over time. That idea, understanding objects at rest, statics, and objects in motion, dynamics, including how fast they move, kinematics, and why they move that way, kinetics, is exactly what defines statics and dynamics in formal engineering terms. This same logic operates at a much larger scale in the real world. From bridges standing still under massive loads to cars accelerating on highways, to aircraft taking off and landing. Engineers rely on statics to ensure stability and on dynamics to predict motion safely and efficiently. These systems work not because of theory alone, but because the same everyday force principles are applied precisely and at scale. The structured understanding of statics and dynamics was later formalized by Isaac Newton, who recognized that motion and force followed consistent mathematical laws. By documenting these relationships, he made it possible for this knowledge to be taught, standardized, and applied across engineering, science, and technology, which is why these principles remain foundational even today. Now that you understand the intuition behind statics and dynamics, the next natural step is to explore equilibrium and free body diagrams, where we learn how engineers translate real forces into solvable models. And that's exactly what we'll break down in the next episode.